So today I am going to teach you in brief about the preliminary geological investigation, preliminary geological investigation for dam, construction of dam on Deccan Trap Rock, then preliminary geological investigation for bridges, construction of bridges on Deccan Trap Rock, and preliminary geological investigation for tunnels, construction of tunnels in Deccan Trap. So you know the preliminary geological investigation. This preliminary geological investigation is very useful. It includes examination of rock and geological features exposed at the surface, at the dam site, bridge site, tunnel, and surrounding area, and it gives a general idea of geological setup in that particular area. Now you know here what is the preliminary geological investigation. I am teaching in very brief due to the time. So in preliminary geological investigation is divided into two parts: surface investigation and subsurface investigation. Surface investigation includes literature review, means you get information about that site or rocks which are exposing at your site, because your rocks which are exposing at your site are the small part of the large unit or large system, maybe of Archean system. Your site may be a small part of Archean system, Dharwad system, Kadapa system, Vindhyan system, Gondwana system, or Deccan. Okay, so you get all information from the books, different publications, etc. Then from the your remote sensing data is also available from satellite imagery, from aerial photograph. You get lot of information. Then topo sheet. The topo sheet from topo sheet you get idea about the which type of morphological feature is present, whether there is a hill, whether there is a valley, whether there is a spur, whether there is a plateau, etc. Means all information you get from this literature. Then the contour maps are available. So get contour map of that particular area, then visit to that area, then collect samples, mark the rocks which are exposing there, then mark the different structural features, fault, dike, then you will get a one map. That map is having the junctions of the rock, and that map is known as the contour geological map, which one you have already used in semester 3 for the construction of different geological section, X, Y, X, Z, like that. You have already constructed geological section in semester 3. Then construct geological section, select 3 to 4 alignments for dam, bridges, or tunnel, and construct geological section along these 3-4 alignments, and select one on the basis of the geological section. That will be your final alignment. Then you have to start, because all information you cannot get from the surface investigation, from surface survey. So for design, the subsurface data is required, or you should know. For without knowledge of the nature of and structure of the foundation rock, you cannot take foundation or you cannot design. Therefore, you can start subsurface investigation to collect information about the subsurface rock or to know the subsurface geology. And for that, you know, two methods are used, the diamond drilling and calyx type of drilling. The diamond drilling is used for drilling in hard rock. Calyx type of drilling is used to drill in soft rock. I am not going in detail. You have already studied this part. Then bit, you know the bit, that is a hollow cylinder of alloy made from beryllium and copper, and which one is rotated by rotary machine, and you will get intact rod of rock, and that rod, solid cylinder of rock, is known as a core. Now, solid cylinder is known as a core. Now, you know the what is a core recovery means. If the drilling is carried out, drilling machine can drill continuously for 1.5 meter. That is known as a one run. After 1.5 meters run, what is your expectation? That length of core should have length 1.5 meter. But and whatever the solid cylinder or core recovered after one run is known as a core recovery, and this core recovery is expressed in a percentage. And these cores are arranged in, after lifting to surface, they are arranged in serially in a core box for the examination. And these cores are again tested into the laboratory, the crushing strain, water absorption. These tests are conducted in laboratory because this data is required for the design. Okay, so this is about the preliminary geological investigation. Now, uh, as far as the preliminary geological investigation for bridges, again same procedure. You have to follow same procedure. Select 3 to literature review of that particular area. Then you will get information about the rock system on which you are going to construct the bridge. Then topo sheet, valley, hill. Then your construct geology, select 3 to 4 alignments, construct geological section, select one, which one is the best alignment, and then start your drilling program for bridges. So, geological investigation is carried out for obtaining data required for the determining foundation level of bridge, scour depth, shape bearing capacity, that is SBC, buoyancy, etc., and to collect sample of foundation material for laboratory testing also. Now, after surface survey, on the basis of the geological section, finally you have selected, the program of drilling is prepared. Means depth of drill hole, spacing in between two drill hole is decided on the basis of the geological section. So as far as the subsurface investigation for the bridge is concerned, drill hole must be drilled at the location of every pier and abutment. There are a number of cases where the drilling was carried out, and at the time of a design engineer located piers of bridge according to his convenience, and therefore the foundation of a pier taken away from actually drill hole taken, and distance between actual drill hole taken and constructed pier was 9.5 meter, and you know the geology changes from feet to feet, and therefore there was a problem. So drill hole must be drilled at the location of every pier and abutment. Take at least 2 drill holes for each abutment. Drill hole should go at least 6 meter in hard rock, and core recovery should be more than 90%. So safe bearing capacity is calculated with reference to RQD and core recovery. Thickness of you have to consider about, you have to think about the overburden also, that is a loose material which one is present above the hard rock, and existence of potholes, whether there are potholes on downstream, upstream, are also taken in consideration. If foundation rock is a compact basalt, very important, because the question can be asked, foundation of bridges on Deccan Trap basalt. You know the Deccan Trap basalt, there are 4 to 5 varieties of Deccan Trap basalt. Compact basalt means you have to take foundation of bridge on compact basalt, amygdal basalt, volcanic breccia, tachylitic basalt, etc. Therefore, I am explaining here in short. This is the bridges, rock type Deccan Trap basalt. First rock type is compact, means the construction of bridge on compact basalt. You know the compact basalt is jointed, and therefore treatment is required to make this foundation rock watertight and to increase the strength. As this compact basalt is jointed, you have to provide treatment there to make this rock watertight and increase strength of that particular rock. Means you can construct the bridge on compact basalt, but you have to provide treatment here. Okay, means you can construct on compact basalt. Then second rock, as far as the bridge construction is construction of bridge is concerned, amygdal basalt. You know the amygdal basalt is the unjointed rock. This rock is impervious, and therefore this rock is the best rock for the foundation of bridge PI. Then volcanic breccia with a great tachylitic matrix, it is also good rain, but don't allow this tachylitic basalt exposed to the atmosphere. Means after excavation in at time of foundation, immediately cover this. Don't allow this volcanic breccia with great tachylitic matrix to atmosphere, because when this volcanic breccia with great tachylitic matrix, it behaves like this amygdal basalt, good rock, but don't allow to expose to the atmosphere. Then volcanic breccia with a red tachylitic matrix, you know the, when it is a fresh, it is a good. On exposure, the deterioration of this red tachylite takes place. Therefore, you can take foundation of bridge on this tachylite when tachylite is a fresh. Then volcanic breccia with zeolite matrix. This you cannot take the foundation of bridge on volcanic breccia with zeolite matrix, because the bond in between the zeolite and explosion fragment is very weak. Therefore, this rock is having very low strain, and this rock is having oids, and therefore this rock is pervious. Means you can take, as far as Deccan Trap rocks are concerned, you can take foundation on compact basalt, but you have to provide treatment. You can take amygdal foundation on amygdal basalt. It is impervious rock, good rock. Volcanic breccia, it is also good rock, but immediately cover. In volcanic is a red tachylite matrix, when it is fresh, good, cover it immediately. Don't allow to expose to the atmosphere. Then volcanic breccia is a zeolite matrix, which is a bad rock or unfavorable rock for the construction of bridges. Then next slide, tunnels. Preliminary geological investigation, you know how the preliminary geological investigation is carried out for the tunnel. So again, literature review, from literature. The next topic is a tunneling. Tunnel, you know, as per how the preliminary geological investigation is conducted for the tunnel. In that again, you have to take literature review, study of topo sheet, then contour map, then take contour map and visit to river site, which one is the small part of the large system. Maybe any system, Indian Kadapa, Archean, Dharwad, Deccan Trap. Then prepare geological map there, collect samples, mark the junctions, any geological feature like dike, fault, and you will have one contour geological map as it was given in your practical semester 3. And from that geological contour geological map, construct 3, 4, 5 geological section and select out of that which one is the best. Select that alignment. So because why we are constructing the geological section, because on the basis of the geological section we can decide the location of drill hole, distance in between two drill hole, depth of drill hole, and therefore these sections are required, and on the basis of this geological section you can select one alignment, and then you have to carry subsurface investigation, that is the drilling is carried out. Now drilling on the basis of geological section, take at least two drill holes, um, 10 meters away from the each portal of proposed tunnel. This one is important. You have to take at least two drill holes at each portal 10 meters away from that proposed tunnel. Then drill hole should go at least 6 meters below the invert. 5 meters below the invert. Then spacing in between drill hole should be 100 to 150 meter. Then you will get drill hole data available for, then the drill hole data will be available for the interpretation. Then construct a geological section throughout the length of tunnel. Mark discontinuities, joints, fracture, fault, water loss and water gain. So this is about the preliminary geological investigation as far as the tunneling is concerned. Now, what is the important? Tunneling in Deccan Trap is an important topic. So compact basalt, first rock you can take, that is a compact basalt, and this compact basalt is a jointed. Means at the time of excavation of the tunnel, roof collapse takes place. Means blocks of the compact basalt come down at the time of tunneling. Therefore, and there is a problem of groundwater also, because this groundwater is known as a enemy number of tunnel engineer. The groundwater initiates all problems as far as tunneling is concerned. And as this compact basalt is a jointed rock, you have to provide support to avoid this roof fall, and the support at the time of excavation and after excavation. And these treatments means you have to provide treatment. This treatment may be steel rib support, maybe rock bolting, maybe shotcreting, maybe wire mesh, etc. And these are method of treatment, and treatment is decided on the basis of the rock system, on the basis of the rock mass classification system. You know that is a Q system of classification, then rock mass rating RMR system of classification, and RASR we have already studied in rock mechanics. These systems are very useful, and on the basis of this system the treatment is decided. So you can excavate tunnel in compact basalt, but you have to provide treatment. So here the diagram is given. See how you know what is the lateral extent of a single compact basalt flow. It is up to 20 km. Lateral extent of single compact basalt flow, and its thickness varies from few meter to 120 meter. Means the maximum thickness of compact basalt recorded in Deccan Trap is 120 meters. So it is shown how is the compact basalt, one compact basalt flow. This is the compact basalt flow. This is the top of compact basalt flow and this is the bottom of compact basalt. So top of the compact basalt flow is always amygdalite and bottom of compact basalt is also amygdalite. So the top and bottom are the amygdala of compact basalt flow and the middle portion it is always jointed. Middle portion is always jointed. So you can excavate tunnel through this amygdala basalt only without any problem. But if you go to excavate tunnel through this middle portion, the tunneling will be problematic. Means you have to face problems. So the best example for best example of tunneling in compact basalt and amygdala basalt is tunnel number 26. The diagram is given here. That tunnel is excavated into that tunnel is at number 26, which one is excavated in flow number 212. Numbers are given to flow and flow number is at 212 through which the tunnel is excavated, tunnel number 26 towards Pune portal. That tunnel is passing through amygdala basalt, means the top portion of the this compact basalt flow, and lining is not provided there. Tunneling was without any problem, but the tunneling, this tunnel passes through the lower portion, means middle portion of this compactor towards Mumbai portal. The tunneling was troublesome and have provided the treatment there and support also. So this is a best example of the tunneling in compact basalt and amygdala basalt. Actually, amygdala basalt here, the tunneling amygdala basalt, you know, the amygdala basalt is unjointed rock without joint. This is a impervious rock, therefore no treatment is required at time of tunneling and after tunneling. So this amygdala basalt is known as the best friend of the civil engineer. Then tunneling in a volcanic breccia is troublesome because this volcanic breccia on exposure to the tachylatic matrix, on exposure to the atmosphere deteriorates and it creates problem. Therefore, best way excavate tunnel through amygdala basalt. So this is about at the time of taking foundation. You can, as far as the dam is concerned, you can take foundation of this dam on this top of compact basalt because this part you are taking foundation on amygdala basalt, which one is impervious. But you cannot, if you take foundation here at the central port or middle part of the compact basalt, the joints are there, and if the joints are frequency of joint is more, and if they are interconnected with each other and they are consistent joint, then the leakage of water will take place. So this is about the preliminary geological investigation for dam, bridges, tunnels, and construction of these bridges, dam, and tunnel in compact basalt or in Deccan Tract area. Thank you.